dealing with this, trying to determine what's going on in the function, we have to see what's going on between the numbers. So here we have plus 2, plus 2, plus 2, plus 2. When you have that situation and all the numbers are the same, you have a linear equation. Now, number 2. This one's a little tricky because 1.1 is 1 and 1/9. This is 1 and 1/3. Okay, so you gotta see what's happening between these. Okay, and 1/3 is really 3/9, so you're actually going up plus 2/9. All right, and then from 1 and 1/3 to 2, you're actually going up 2/3, or 6/9. And then going from 2 to 4, easier. You're going up 2, and then you're going up 6. Now, what's happening from here to here is actually times 3. 2 times 3 is 6. From here to here, times 3. 6 times 3 is 18, divided by 9 is 2. And then times 3. So when the second, this is a tough one, but when the second level is going up by multiplication or division, you know you have exponential. Specifically, this one is exponential growth because the fact is going up by times. The division, it would be decay. Now, if you had a tough one like this, you could really literally just kind of graph this generally, like -2, 1, and then -1, a little bit higher, and then 0, 2, and 1, 4, and 2, 10, and you can see what's happening there. So if you want to, you can do that. Even on number 1, if you're not sure of these, you forget, go back to what you know. Make a little quick graph. You know, -2, -5, you drop down here. -1, -3, 0, -1, 1, 1, 2, 3. Oh, that's linear. You can sketch that out. Or give me graph paper, have it handy. It's usefully, check it. So what's happening here? -2. -2 plus 2 plus 2. Well, that's kind of weird. Well, it's going down this way, and then it's going back up. That is absolute value. And again, you could graph that just generally and get an idea what it looks like. All right, -6, -2, plus 2, plus 6. Now notice, as opposed to absolute value, this is going down down and back up different numbers. It's still going to have that same general shape, but you're looking now at, I don't know, let's see. -2, 7 will be up here, -1, 1 will be like here, 0, -1, 1, 1, 2, 7. Oh, that's going to be a parabola, which is a quadratic. So again, go back to what you know. If you have trouble, if you forget what they mean, what the patterns mean, just roughly sketch it, and you can figure out what it is. Okay, transformations. Again, if you forget this, do not worry. Take your calculator and go, wait, okay, this is like y equals x. Oops. Y equals x. And this one's basically y equals x squared. That's the parent function. And this one is y equals the absolute value of x. And this one here is y equals x cubed. And this is y equals 2 to the x. And this is y equals x squared. Now you should hopefully by now have a general idea of what these look like. But if not, take your calculator and put in y equals x. And graph it. It's a line. It's linear. Okay? So first off, it's linear. Next, go back and go y equals 2x plus 5. 2x, nope, wrong x. X plus 5. And hit graph. Well, what happened? Well, it's steeper. And it's up 5. All right? You hopefully recognize that. The steeper, technically, you would say it's stretched vertically. It's climbing higher, faster. All right? On other shapes, we talk about being thinner. But there you go. All right. Now, if you need to fast forward to the calculator part because you understand it, that's fine. Okay? So we clear up. And we say this is y equals x squared. Well, that's a problem. Now we go back up and go here and say, well, I have parentheses x minus 2. Parentheses, oops. Yeah, that's right, squared. And then I have plus 1. Hopefully you know that plus 1 is going to move it up 1. But which way does it go, left or right? Negative 2 means you think left, but it's actually right. So you can see how it went right 2 up 1. So, coming back here, it is a quadratic. You can abbreviate quad. And transformation, it's going right 2, and it's going up 1. And even if you're pretty sure you know it, why not take the extra 30 seconds to type in the calculator and verify it? Okay, y equals absolute value of x. So, come back here. You should know what that looks like. It's going to be a v, so I'm not going to do it twice. So remember, absolute value is under math, over to number, and there it is, number 1. And it's just x. Now for number 2, again, math, number, absolute value, and this one is x plus 1. And I just realized I made a mistake. I forgot to put something in front of it. So I'm going to do second delete. See, it says INS, that's insert. And I'm going to put negative 3 divided by 2. Now remember, what is negative 3 over 2? That's negative 1.5. So there's my original one. Look what happened. The negative makes it go upside down. Flip over the x-axis. The 3 over 2 makes it narrower. And the plus 1 moves it left 1. You can see all of that. So first off, again, it's absolute value. All right? Now, it went flipped over x-axis. It moved left 1. Even though we see that plus 1, we got to do the opposite. So it's left 1. And it was narrower, thinner, however you want to put it. Number 8. Okay? Hopefully you recognize this as a cubic because it has a 3. Okay? And hopefully you remember what it looks like. It's a snake, north to south snake. So I'm going to come back here to my y equals. I can remember to do the order of the buttons. Clear out what I've got. And come up here and type in x cubed. Nope, that's not what I want. X to the third power. Nope. Try again. One more time. Third time's the charm. Okay? Now, I want to put in 1/2. I can put 1 divided by 2 or 25. X to the third power. That's 6. Remember to come back down. And then do minus 3. Hopefully you know that minus 3 is going to move it down. So here's my snake. Okay, you can see it dropped down. It's also a little wider. Okay, a little fatter. All right. So the 1/2 is going to make it wider. The negative 3 is going to move it down 3. That's it. All right, 2 to the x. That's exponential growth. If this was a fraction less than 1, then it would be exponential decay. Hopefully you already know this is up 2 at this point. And you look at that and go, oh, -1 means left. Nope, it means right 1. But let's use my calculator to verify. So I go to here, I clear out what I've got. I say I want 2 to the x. That's my exponential growth. Then I want 2 to the x plus 1, sorry, x minus 1, come down, plus 2. Here's my parent graph, exponential growth, and here comes my translated. It's higher, up 2, all right, and it's shifted to the right a little bit. Okay, x squared, hopefully you realize that that is a parabola, so that is a quadratic, like number 6. Alright? This -1, hopefully by now you got it, it's down 1. The 3 is going to make it narrower, thinner. But again, if you need to, come back here, clear out. We already know what x squared looks like, but I'm going to put it anyway. Come down here and clear this out. And I'm going to have 3x squared minus 1. Get graph. Here's my original parabola. And here's my narrower, thinner one, and down 1. Okay, number 11. We already know 11 is absolute value. So it has the absolute value bars. Again, we should use our calculator to graph this. That's what it looks like. You get all those points off your graph, off your calculator. Now, x plus 1 minus 3. So I'm just going to graph that one. Math, right over there. X plus 1. Come outside the absolute value bars, minus 3. Graph it. Lower and left. All right? So I can go to my table and get some points. Okay? But also, if I know what's going on here, this means down 3 on the outside. This means left 1. We just saw it. It was left. So I can literally just go left 1 down 3. And I just move my vertex. And then literally every point there out on that 45-degree diagonal. Again, I can use all the points of my calculator to make it smoother and get more exact points. And if your test says use 5 points, then please use 5 points. Now, domain, remember, we're not putting numbers like 2, 3, 4, 5, 6. When we're looking at a graph, the domain is going to be using infinities, usually. So left to right is going forever both directions. Now, how low does it go? Well, -3. And it actually hits there. How high? Infinity. Right. X squared is a quadratic. Okay? You can use your calculator to get the points, or just do it in your head. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And then on the opposite side, negative, and so forth. And then you have your nice, well, should be nice, parabola right there. Now, negative means flipped over x. This means left 1. This means down 2. Now the problem is you can't just go left 1, down 2, and then redraw it. You could if it was positive, but we need to flip it. So I would suggest you use your calculator. Come to y equals, clear it out. Your negative key, parentheses x plus 1, parentheses squared plus 2. All right? Now, you're going to disappear on me, but I can go back and forth. So second graph, and I want to just get some points. Negative 4, 7, negative 3, negative 2. Negative 4, negative 7. Negative 3, negative 2. Negative 2, 1. And negative 1, 2. 0, 1, and 1, negative 2. And you can see what is happening here. You can see it's flipped over. Sorry, why did I write up, down 2? That was just silly. Hopefully some of you are yelling at me saying, Mr. Yogi, you're screwed up. Because plus is clearly, let's move back to 0, plus is clearly up 2. Which, nicely, you make a mistake. If you look at your graph and the calculator, you go, wait a minute, that's moved up 2. It's moved left 1, up 2, and flipped over. So, the domain, how far left does it go? Again, this is the infinity one, forever. The range, how low does it go? Negative infinity. If you ever can't forget, I'll come back to that. How high does it go? Goes to 2, and it's inclusive. Now, a lot of times people want to do this. They do 2 negative infinity. Now, that's, it's just in the wrong order. But remember, if you need to, negative infinity is out here, positive is here, negative infinity is down here, positive infinity is up here. Put those on your graphs to remind yourself, where is negative infinity? It's on the left. So we're not going to write it this way. All right, 1/2 to the x. That is exponential. But since it's 1/2, it's actually decay. So let's give us some nice numbers here. 1/2 to the x. So y equals, clear it out. I use 1/2, I use 0.5 to the x. There's my decay. It's never going to hit 0, is it? So I go to my table, and I want 0, 1, negative 1, 2, negative 2, 4. Zero, 1, negative 1, 2, negative 2, 4. Negative 3, 8, that's all I can do. Negative 3, 8, right there. And remember, it's going to come down, and get closer and closer and closer, and never hit 0. That's my parent function. Now, you should know by now, what's that going to do? That's going to move it right to, and this, as I just showed you, is up 1. So again, I can use my calculator, or I can literally take each of these points and move right to up 1. Right to up 1. Right to up 1. Right to up 1. And remember, it's never going to hit 1 this time. So when I come down, I'm going to just be 1 higher than the other one. So the domain, how far left? Forever. How far right? Forever. How low? It's never going to hit 1. So I use parentheses, not a bracket. And how high? Positive infinity. Square root of x. Okay? So that's literally just a square root function. What does square root look like? I've talked about that for y equals, clear it out, second square root x. Okay, and we do this with just our math in our head. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. All I put in was numbers 0, 1, 2, no, sorry, 0, 4, and 9, my perfect square numbers. Took the square root of them. I got 3 points and horribly drew a line. Now, this is going to move left 1. And this is going to move down 3. So again, I can take each of these points and literally go left 1, down 1, 2, 3. 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 And then draw the same, only a little bit better, like that. Again, or I could take my calculator and go to y equals, go down here and do second square root x plus 1, come outside of it, minus 3, and just confirm I do the same thing. There you go. And then you can use your table to verify the points or do the points. And just look for whole numbers. And I'm on y2 for that one. So there's 3, negative 1, which I did, 8, 0, which I did, and so forth. I'm done. That's all I can do. Now, my domain, how far left? Remember, we're talking about the transformation. How far left does it go? Well, it goes to negative 1, and it actually hits there, out to positive infinity. How low does it go? Negative 3, it hits there to positive infinity. Another way to find the domain is just to set x plus 1 has to be greater than or equal to 0, right? So x has got to be greater than or equal to negative 1. Okay, a few more of our graphs here. This is going to be a longer video just because of all the calculator stuff. So, cubic function. Remember, that's our snake. I don't know why I just put an S there. That's for snake, I guess. Cubic function. So let's pull that up. Y equals, clear, clear, back up here. X to the third power. Graph. Okay? I can do this without my calculator table. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. And that's as far as I can go. Negative 1 cubed, okay, is negative 1. Negative 2 cubed is negative 8. And there is my cubic snake. Now, the negative here, we can say it's flipped, we call it reflected, whatever you want to do, and this means up to. So, I would definitely use my calculator for this one. So I go to y equals, come down here, and do negative x cubed, come down, plus 2. See how it's a little higher? And now use my table to get those points. Remember, I'm using y2 here. So 2, negative 6, and 1, 1. So 2, negative 6, and 1, 1, which we're doing again. Then come up and get some more points. 0, 2, and negative 1, 3. 0, 2, negative 1, 3. 0, 2, negative 1, 3. And it was negative 2, 10. And so that is going to look like so. The domain of my transformation, Again, going forever and ever both directions. And low to high, same thing. Forever and ever both ways. All right, the beauty and fun of piecewise. Remember, there's multiple ways to do this. One way to do it is graph the whole thing. All right? I'm not going to do the calculator for this part. I'm just going to pretend I use a calculator. So remember, this is y equals. Y equals 3. So I'm going to actually just graph y equals 3. That's a horizontal line. If you don't remember, don't guess. Don't go, well, I don't know if it's that, or maybe it's this. Don't guess. Put in your calculator and figure it out. It is a horizontal line at 3. But then, I only want x's less than -2, which means I'm going to be cutting along this dotted line right there. So I'm actually going to put a circle, an open dot here, because it's less than, not less than or equal. And then I just take my eraser and just do that. So I literally draw the whole thing and then cut. X squared minus 2. I can use my calculator for that, or just draw it based on what I know. I know my usual one is at 0, 0, but it's going to drop down 2. I know my usual one is at 1, 1, but it's going to drop down 2 and match over here. Usually I'm at 2, 4, but it's going to drop down 2. Usually it's at 3, 9, but it's going to drop down 2. And then there is my quadratic function. But I only want between -2 and +2. And I want this to be a solid dot and this one to be an open dot. So I'm going to get my eraser out again. I don't want anything above that point right there. And I want it to be -2, +2. On the other side, I don't want any of this. Okay? But at -2, +2, I want an open dot, and I just want that little piece of that forever. And then, -1/2 x minus 5. That's a linear equation. That's starting at -5, and it's going down 1, right 2, up 1, left 2, up 1, left 2, down 1, right 2. And here's this beautiful line that I not want the whole thing of. I only want greater than or equal to 2. So I'm going to come to +2 and drop down and put a big old dot right here. And I want greater than, so I don't want this side of it. And that's it. That's my piecewise graph. Now, that's one way to do it. That's a longer way to do it. The somewhat easier way, I believe, is go to y equals, go to y equals, clear out what you got. Now, put in y equals 3. Okay? But then use your table and say, I want everything less than 2. So I go to x, and I don't want, well, I almost want all this. There. I don't want 3, do I? I want less than 2. So I put 2 at the very bottom. And I just plot those points. 2, 3, 1, 3, 0, 3, and so forth. And I make sure to put an open dot at 2, 3. Next, I go here, and I put x squared minus 2. X squared minus 2. I graph it and see the traditional parabola. But then I say, you know what? I only want between -2 and +2. So I'm going to move down so -2 to the top. And I'm literally going to just take the top 1, 2, 3, 4, 5 numbers. -2, 2, and put a solid dot. -1, 1, 0, -2, 1, -1, and 2, 2 with an open dot. That's all I want. I don't want 3, 7 or anything else. I want between those two numbers. And last but not least, I put in 1 divided by 5. No, sorry. -1 divided by 2, or 0.5. X minus 5. And I graph it. And here's my beautiful negative line, negative slope. But remember, I want greater than or equal to 2. So I go to my table, get rid of -2 and -1 and 0 and 1. And that's what I want. 2, -6, 4, -7, 6, -8, 8, -9, and I have my line. Now, evaluate h of -2. All right? Well, I go to -2 for x, and I look for a solid dot, and that's at 2. H of 6, solid dot, right there at -8. -3, no dot, but there it is at 3. Now, some of you like to plug stuff in instead of looking at the graph. Well, you go, which one do I plug into? Well, -2. Well, that can't be this one because this is greater than +2. This one here is less than -2 with an open dot, so it has to be on the parabola. H equals 6. That is the third one, greater than or equal to 2. So I would plug it in there. -1/2 times 6 minus 5 is -8. And then -3, that's going to be this one, less than -2. So that's how you find out which one's which. All right, this one's kind of a fun one. Domain. How far left does it go? Well, right here, -7. And that is with a bracket because it's a solid dot. How far right does it go? Right there to 9 with a bracket. Range, how low does it go? Right there, -7. And how high does it go? 8 with a bracket. Next page. And the last page. No, that's the last page. Unit 3 is a big one. This is going to be a longer video. Number 18. Determine the equations that make the piecewise function. All right. Well, we're just looking at what's going on here. So let's look at this one first. Well, let's determine what the slope is here. We have points here, here, and here. So what's my slope? It's up 1, right 2. Up 1, right 2. Up 1, right 2. There is my y-intercept. So if this line was whole, it would go through right there. So that means y equals negative something x plus 5. Now, what was my slope? I counted. Up 1, right 2. That's not positive. I don't know why I put a negative sign there. Because I'm going up and right. My line is positive. That was just silly. All right? So that's that one. But remember, I need to cut it. So it's when or if x is, as an open dot, less than, where's that dot hit? -2. X is less than -2. Now let's look at this one. This one has a slope of +1. Up 1, right 1, up 1, right 1. So down 1, left 1, down 1, left 1, down 1, left 1. There we go. So where does it hit? That is y equals, my y-intercept is -1, and my slope is +1. That's it. Y equals x minus 1. But remember, I don't want the whole thing, do I? No, I do not. I only want x greater than 3. If x is greater than 3. No solid dots, so no greater than or equal, less than or equal. Now, what about this bad boy? That's a vertical line. I'm sorry, a horizontal line, which is y equals -4. When or if x is, look, less than 3, greater than -2, and they're solid dots, so it's like that. It's between -2 and 3. And that's how you work backwards for piecewise. All right, everybody's favorite fun time activity, functions. So, f minus g. We're going to take this minus this in parentheses. Be careful. 2x minus 1 minus 5x squared plus 2x minus 3 minus, we are not timesing. We are not going to multiply 2x times everything and negative 1 times everything. We are just distributing the negative here, here, and here. 2x minus 1 minus 5x squared minus 2x plus 3. Now you put everything in standard form. Negative 5x squared comes first. 2x minus 2x, well, they just cancel out. And 3 minus 1 is plus 2. That's it. Half of x, 2x minus 1, minus g of x, which is 5x squared plus 2x minus 3, plus h of x squared minus 4. Hey, here's a little cheat. We already know what this is. It's negative 5x squared plus 2. And now we just have to add x squared minus 4. So negative 5x squared plus x squared is negative 4x squared. And 2 minus 4 is negative 2. That was kind of a shortcut. G over f, we literally just write this. 5x squared plus 2x minus 3 all over 2x minus 1. G over f. But we're not done. Because remember, we have a fraction with a letter in the bottom. We cannot have a 0 as a denominator. So what would make 2x minus 1 0? Well, let's find out. What would make this 0? Add 1 to both sides, divide by 2, x equals 1/2. It can't be 1/2. So remember, you need this and this for full credit on a problem like this. 22, we're playing the whispering game, the telephone game. We're going to plug negative 3 into f, get a new number, so story's going to change, then plug that number into h. So starting with f, 2 times negative 3 minus 1. That gives me negative 7. That I'm going to plug into h. Negative 7 squared minus 4. Please, please, please remember, don't just type negative 7 squared in the calculator and get negative 49. A negative number squared is positive. This is going to be 49 minus 4, which is 45. Do not make that mistake. Please, 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 please. A negative squared is always positive. Either put your calculator with parentheses or just do 7 squared. 23, f of g of x. I'm sorry, not of. It's a solid dot. This means multiply, times, all that good stuff. So now, what I told you not to do in 19, we're going to do it. 2x minus 1 times 5x squared plus 2x minus 3. We finally get to multiply. 2x times everything. Negative 1 times everything. 2 by 3 is going to give us 6 terms. 2x times 5x squared is 10x cubed. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Now we just make everything negative. Minus 5x squared minus 2x plus 3, which we already had in the first two problems. Now, join like terms. Well, 10x cubed has no friends. Boom. 4x squared minus 5x squared is minus x squared. Done with those. Negative 6x minus 2x is negative 8x. We're done with those. Plus 3. Finito. Telephone game. Okay? But this time we don't have a number. We're just plugging f into h. A little bit different. So we have h, which is x squared minus 4. We're plugging f, which is 2x minus 1, in here. Now again, you should be able to do the shortcut by now, which is very simple. You square the first term. It's kind of like soap, really. It's very similar to what we do with soap. So we're going to square the first term, 4x squared. We're going to multiply and double, a little different from soap. So negative 2x double is negative 4x, and then square the last, plus 1 and minus 4. So that's going to give me 4x squared minus 4x minus 3. If you struggle with that, then you're going to have to come off to the side and FOIL, distribute, multiply, whatever you call it, 2x minus 1 times 2x minus 1. First, outer, inner, last. Hello, Stewie. Okay, last two on this page. And then there's only one page left and we're finished. Okay, this is how we're plugging F into G. So what does G look like? Well, G is the 5x squared plus 2x minus 3. And what are we plugging in there? We're plugging in F. So the 2x minus 1 goes here, the 2x minus 1 goes here. Now the nice thing is, we already did this on the previous problem. So that's going to be 5 times 4x squared minus 4x plus 1. We already know that. Plus 2 distributed, 4x minus 2 minus 3. Now we distribute 5. That's 20x squared minus 20x plus 5 plus 4x minus 2 minus 3. All the parentheses are gone. 20x squared, no friends. Done. Negative 20x plus 4x. Negative 16x. 5 minus 2 minus 3 is 0. Finito. We're playing the telephone game again. We're going to plug 2 into F, get a new number, plug that new number into G. So F is 2x minus 1. But we're plugging a 2 in for the x. So that yields 2 times 2 is 4 minus 1 is 3, which now we're plugging into G. So 5 times 3 squared plus 2 times 3, so x, minus 3. 3 squared is 9 times 5 is 45. 2 times 3 is 6, minus 3. 45 plus 6 is 51, minus 3 is 48. We're almost there, hang in there, almost complete. Determine if these are inverses of each other. So what I'm going to do is I'm going to take this 27, and there's two ways to go about doing it. Okay, yeah, later I'm going to do composition of functions. So what I need to do is determine the inverse. I'm sorry, I totally misread that. I'm getting ahead of myself. So step 1, make this into y equals 2/3 x minus 4. Step 2, switch these. X equals 2/3 y minus 4. Now, solve for the new y. Add 4 to both sides. I get 2/3 y equals x plus 4. How do I undo 2/3? I multiply by 3 halves. And I multiply by 3 halves here. Cancel, cancel. Y equals, I can say 3 halves x plus 3 times 4 is 12, divided by 2 is 6. Or 3x plus 12 over 2. Same thing. Again, y equals x squared plus 4. Switch them. X equals y squared plus 4. Minus 4, y squared equals x minus 4. I need to undo the squaring by square rooting. Remember, anytime I square root with an equal sign, I'm going to need a plus or minus in my answer. So square root of y squared is just y. Equals plus or minus, just that's it, x minus 4. finished. All I need to do. Easy peasy. All right, I'm going to take this and pop it in right here. Then I'm going to pop this in right there. If I get X for both of them, see, this means plug G into F, plug F into G. If I get X for both of them, I'm good. So, 3/5 X, 5X plus 10 over 3. Okay, well, I'm just multiplying. So my 3's cancel. I get 5X plus 10 divided by 5. And I forgot my minus 2. Can't do that. So, this is really 5x over 5 plus 10 over 5 minus 2. Well, that's x. 10 divided by 5 is 2. Minus 2 is 0. That gave me x. Yeah. 5 times 3/5 x minus 2 plus 10 all over 3. I'm going to distribute 5. 5's cancel, which gives me 3x minus 10 plus 10 over 3. Minus 10 plus 10 is 0. 3x over 3 cancels, leaves me with an x. Yes. So the answer is, don't forget the answer, yes, they are inverse functions of one another. Again, I'm going to take this and plug it in there. So, square root of 2x plus 5 squared minus 5 over 2. Well, this cancels that. So that leaves me 2x plus 5 minus 5 over 2. That's 0. Those cancel. I end up with x. Now I'm going to plug this in there. Big old square root. 2 parentheses x squared minus 5 over 2 plus 5. The 2's cancel, leaving me